Howdy, WAF guy here with WAF Logic, back again with our next video in our WAF Life series. So that was a bit of a delay, and apologies for the wait for this video, but projects do take precedence over our free media education efforts. And after all, the world is always on fire in the WAF life. It's called the firewall for a reason. Now today in our video, zero-day mitigation, WAF Beat Down Story, we're going to demonstrate how to build an advanced WAF policy and even prevent some 0 days for ever and a day. We'll focus on mitigating the DVWA or damn vulnerable web app so it ain't so damn vulnerable anymore. Well, at least perceivably to the attacker, since we'll pretend this is our company's web app that's last updated in the summer of 1998, but must remain live and can't be fixed or patched because of reasons. Business always supersedes security at least for now. Now, to add a little extra spice to it all, I'll actually be disabling the attack signatures or rules, as some other WAFs will call them, so we can demonstrate with proper controls, it is actually possible to mitigate many to most, and sometimes all, potential attacks with the right policy. Now, there certainly are limitations, but where there is a will, there might be a way, especially with F5 and 9 rules. Now, it is important to note that the robust features I'll be presenting today are specific to F5 ASM and Advanced WAF. All the other WAFs have a much more limited capability to provide these mitigations, if it's even possible, especially if cost versus security has to be considered. That could be dangerous. But a great example would be AWS and Azure, since these mitigation or zero-day controls I'll demonstrate cannot be done without very expensive regular expression-based rules. Now, even if you can get close, you will pay a hefty computation fee to get the job done. Versus F5, this is just kind of out of the box, the package that you pay for. It's just basics, and ideally should be. AWS and Azure's capabilities, versus cost here is kind of like paying $20 for filtered municipal water. That's pretty sad, but it's actually a fair comparison. Now, this becomes more financially dangerous with AWS and Azure if you have to mitigate a true 0 day before the managed rules includes a solution. Bash Shell Shock is a great example from back in the day because there actually was nothing at that time. We had to create stuff until the vendors created one for us. Now, this is very important consideration when choosing a cloud-based solution with a CPU, RAM, and throughput cost model, which is 100% unpredictable, versus your normal, all-inclusive, very predictable cost model for a security product outside of, things like subscription-based services, maybe like IP intelligence or something like that. Now, in our last video set, part 1 and 2 of chapter 2, WAF logging and all your database are belong to us, we showed a database exfiltration successfully performed, and in our case, we leveraged the WAF to provide the detection, however, no mitigation. The intent was to essentially show the WAF could have done, and more so for educational intent, to provide us the logs without mitigating the attack so we could perform our security analytics so we could do our WAF stuff. Now, additionally, this is a legitimate scenario in the WAF life where one would start the evaluation of a WAF, often called a proof of concept or POC. Does it do anything? And does it do what we're buying it for? Now, there are two critical items any and all security technologies must provide. Number one, detection and or mitigation with adequate logging ability. And then number two, a simple, repeatable, predictable, very important process to handle false positives, because ideally they will happen. Now, number two is exceptionally important in the WAF life, because if you have a good WAF, it will produce false positives to some extent out of the box, which is why they require tuning and some advanced skills to manage them. Now, most security products are binary, ones and zeros, on or off, or allow or deny. Some technologies and or features have a more logic and or weight driven approach, but This also often includes what I refer to as I'm not sure logic. And the issue with I'm not sure logic is when a security technology is not sure, it tends to not log the event and certainly did not take any action. So if the single attack to steal everything and burn the entire company down to the ground is initiated and the I'm not sure logic kicks in, the attack is allowed and usually unlogged from the security perspective. So, I mean, because false positives are just too hard to handle. I certainly beg to differ, but that comes from a lot of experience and skills and just being able to manage those. So, to complicate that scenario a bit more, you as the analyst or engineer can go ahead and replay the attack, since somehow you magically discovered it through some other means. So you do, and you find it gets actually blocked since the I'm not sure logic saw that event twice now, but not in no other context. And now it's pretty sure or certain it's bad. So it blocks the analyst or engineer's attempt despite allowing the original attack through. Now, hopefully, you wonder why the WAF didn't have an event previously and consider the attack may have succeeded, so you dig further. But some folks would simply write it off as the WAF blocked it, so nothing to see here and move on. In our case, we know that it didn't for our mock scenario. But let's take a look at the true reality. Because the first attack was considered, I'm not sure, it was allowed. So now the damage is done and you have zero evidence since the WAF was your only detection point of a true attack since the web app is vulnerable in this scenario. So even if the attacker replays the attack again, which the WAF might block this time, they likely won't replay it since the damage is done and they already have what they came for. So the end result is you were 100% blind because of the I'm not sure logic. And now when you get to go ahead and attend your federal congressional court hearing and the Inquisition asks you, how did the attack occur? Well, your reply gets to be, I'm not sure as well. I don't think that hearing will be going very well for you. Now, with the ones and zeros standard approach, the attack would have been blocked in every single situation, unquestionably, if it was ever detectable at all to begin with. 100% predictable versus the I'm not sure logic, which is often proprietary, in other words, closed source design, essentially is fairly, if not completely unpredictable, thus significantly less reliable. So get on with it, all right? All right, sorry, we just had to get through the, we had to get through the shrubbery first to set us up for this series, but this one will be hands-on and hopefully a lot more fun. So how are we going to mitigate a 0-day with our awesome sauce WAF? We'll go and start with SQL injection and kind of move on through DVWA, but here we go. Alrighty, here's damn vulnerable web app. Now, we presented the log exports in our last video for the database dump. We'll be protecting the vulnerabilities, the vulnerable parameters from that attack here. We'll also walk through most of the DVWA attack scenarios and provide protections with the WAF for each one. Brute force and capture require a different level of controls beyond the basic WAF. So we'll cover that in a future video, and we'll also be discussing our magic true DDoS solution project Bayou on that one. So first, I have to start with the F5. As said, I will disable all the signatures. So go ahead and do that right here. And then apply. All right, now our signatures are disabled. So we're going to start on DVWA and the SQL injection. This is the one that we did attack before. So we'll take note of our URI. And we'll go over to our F5. And come over to URLs. Now, in a lot of situations, you can create global parameters. And in this case, we will do that. But just for the sake of kind of building a WAF policy structure, it's not always required, but sometimes it gives some context on what you're designing and helps you have something to reference back to remember what the web application actually looks like. And sometimes eventually you may be creating these URLs down the road. Do I always do this? No. It just depends on the situation. So in this case, show and tell, kind of go a little extra, a little further than I normally would. But then again, as said, there are plenty of situations where I will automatically do this. So because the URL very specifically was DVWA vulnerability SQLi, I'm going to go ahead and create a wildcard because in this case, I know DVWA is actually the created path that we designed versus it being a default path, which is vulnerabilities and SQLi. So in this case, if anybody changes the root structure, this policy will always apply. So we're going to run with that and we'll wildcard it. And does not include slashes. And we'll go ahead and create that. Next, we'll go and create the parameter. Now, the two parameters. Now, if you reference the logs, you'll actually find these within there. I'm not going to reference them for the sake of time in this case, and we've previously covered it. So go watch the other video. All right, let's go ahead and create some parameters. Got a handy little plus button, so we'll start with that. And I'm going to call it ID. Now, ID, in this case, that's what we see here. Now, let's go ahead and take into consideration what we're looking for here. This is a user ID. Now, clearly, this implies there is no limitation, or there is, and it's just really long. So, nonetheless, typical user IDs are 8 characters, sometimes 16, 32, 128. They fall within those, standard computer byte ranges. So in our case, we have to consider that. And a user ID, we'll consider an email address because email address would be the lengthiest user ID that you typically see. So we'll just kind of look at it from that perspective. Jim Bob Jones at yahoo.com. So with this, we'll go and submit it. Now, with our fancy developer tools, we'll go ahead and take a look down here, and we can see there is actually no request payload. We can also note that it's a GET under our method, hence no payload. It just happened to be default there. It's where I was last at. Moving on. The URL, we can see, actually includes the parameters directly rather than within a post body. Okay, no big deal. WAF doesn't really care. Treats them equally the same, depending on which WAF you're talking about. Could be different. So in our case, we're going to go and protect the ID and the submit parameters. And as we can see here, both are used. So we'll go ahead and roll with that, and we'll keep the ID. So we'll pretend the ID has a maximum length of 128 characters. Kind of fits within the realm of email addresses. Yes, technically it can be longer, but I've seen plenty of web apps actually put limitations to 128 characters, including many authentication systems. 128 characters, just kind of like a de facto limit that's already been predefined in many systems. Kind of like 32 characters is a common length for password limitation. Not as true so much anymore, but moving on. So in our case, explicit parameter ID, and we're not going to do staging because we know we know what we're doing here. Now, empty value. In our case, this one can be dangerous just because if you refresh the page, it's very possible that the ID would be blank, but still may be present and called. So because we do not want to impact our user negatively for a very potential normal situation like refreshing the page or expired timeout, we will go ahead and leave this enabled. Now, for repeated occurrences, this is a singular function in this case due to this form because it's a single ID lookup. But because we are using a global parameter, it is potential that this parameter could be used elsewhere, such as a multi-ID lookup form. So we have two choices. We can either go very specific for this URI, as we created earlier, or we could, again, go for the global aspect, which we will. And then with that in mind and the genericness of ID and how it could be used elsewhere, particularly in PHP forms where ID references kind of like a certain column in a database versus an ID as a user ID, numerical versus words. These are things to consider. But for the moment, what we see, we know it's a user ID in the standard context. So we'll keep that in mind. And because we've reviewed the rest of the web app in this case, we know there is no multi-ID lookup. So we will actually not allow repeating occurrences for the ID parameter. Now, moving on to the meta characters, we'll go ahead and enable the checksum here. And this is where the real power comes into play of what you can do with the WAF, and a big reason on why we can get away with not enabling the signatures and still provide 0-day or at least close to type mitigation in many instances. Not all. There are plenty of situations where you pretty much need signatures or alternative solutions, such as DDoS or account authentication verification. But we're just going with the basic WAF stuff for today. So moving on here. For a user ID, a space is actually not appropriate, nor is exclamation, hash symbol, no. And then we'll go down and these ones, not acceptable either. Now with asterisk, asterisk is a little unique because in some authentication systems, there's been an attempt to hide PII data, and I mean, it's kind of appropriate, but it's really kind of a nightmare for security analytics when you hide the user ID, mask it. So you have a user ID with, like Jim Bob Jones, and all you see is Jim asterisk asterisk asterisk, and they don't even match up to the full length. It's just, an arbitrary set number of fixed number of asterisks. It makes it very difficult to do security analytics, and it gains you very little. However, in some efforts to defeat PII being logged, some developers have gone through and provided this solution, if you will. And it's a poor solution. In fact, it actually really achieves nothing. The auditor really probably wouldn't even care. You certainly won't get any bonus points for it. Nonetheless, it has been seen. So, taken into consideration, we may need to add this, but in the review of this web app that we've done, we actually know that we don't. So we'll go ahead and move this to the disallow area. Now for dashes, well, user ID, I mean, that's kind of pretty typical. So we'll go ahead and keep that. Slashes and colon, no. And then question mark, certainly not. At, well, could be an email address, so very potential. We'll keep that. And then caret, absolutely not. Never used, nor is the tilde. And we'll just go ahead and add in the comma. We will keep the plus because I have seen some situations where the plus symbol is actually used, but not always. So we're not totally sure because we don't know the full back end aspect of the system that we have here. And who knows, maybe normally it actually uses all user IDs like email addresses. But then in some rare instances with a very specific account, you'd actually have to use a plus. So we'll go ahead and keep that in mind. And sure, we'll actually add that one. And with that said, we can go ahead and create our parameter. Give it a quick review. Looks good. All right. And one thing we'll actually cover real fast here too. We'll take note that I did not select attack signatures. We'll enable that later, but for the moment, it's not part of the intent because we want to demonstrate the ability to mitigate these without signatures and then add the additional awesome sauce of signatures to catch all the other amazing thing or all the other really bad stuff and really just provide a lot more detail for the things that we do detect and mitigate with these controls already. So, I mean, essentially, the more evidence you have for any given case, the more weight you have, and certainly the more viable your conclusion would be. So, with that said, we'll go ahead and go back. Now, coming over here, we have our ID parameter that we had talked about and just created. We also have the submit parameter to work on. Now, keep in mind, we do see a capital S here. And for the value, we see submit with a hash symbol in the actual URL. Now, we see down here, there is no hash symbol. And then coming over here, there is no hash symbol. So this creates a bit of confusion. In our case, the web browser is doing some decoding for us to make it more pertified and easily readable, but the WAF doesn't see it that way. The WAF sees exactly what is sent. There's no assumptions to be made with the WAF. There's only assumptions to be made how you design and configure the WAF. So again, ones and zeros. And that's what we like because consistency. That's very, very important. So we'll come back over here and create our second parameter for submit. Now, it's important to note that this policy is case insensitive. So even though the parameter in itself has a capital S, it doesn't matter because the policy is case insensitive. So when I type it as a capital S, when I save it, it will be lowercased. Now, this is very specific to the ASM F5. So other WAFs do handle this differently, and different elements within the WAF can handle case sensitivity differently, even within the F5. Despite case insensitive, globally, it's not necessarily entirely true. We'll cover that a little bit later, but nonetheless, we'll go and create it for demonstration purposes with capital S, because it doesn't hurt you. Now, we're not going to do perform staging. And in this case, as we see with the web app, it has the value of submit. So in other words, it's a word. And also a phrase in some of the other aspects of the site that we come across. And it's not uncommon for it to be a phrase. So essentially a word or a phrase, but it's limited. It's not like a comment field or a user ID. So there's some context that we can kind of predictively assume here and roll with. But the key thing is it's a singular function, so it's not going to be repetitive. So we will not allow the repeat. But because of the ability to refresh the page and potentially have a parameter called but not have a value called, that would be appropriate. So we'll go ahead and allow the empty value in this case as well. Now, for the length to the word and phrase consideration and for application development, they tend to like the approach of simple. You don't want to get too complex in your button naming convention unless, of course, you have a really complex naming convention. In this case, we don't really have one. So It's very likely to assume, and based upon our evaluation, we do know that it's very limited scope. So we'll go and give some flexibility for future design, and we'll go and give the length of 16. Again, my little 8-bit values that I kind of like, but it at least gives us a degree of control for length, because the button value would not be 2000 characters long. So we do ideally should imply some kind of limitation. And we know it's not going to be 128 characters, certainly not in our situation, but we'll go ahead and roll with 16. Just sounds good. I could do 8 if I really wanted to, but in this case, it's a little too stringent, and 16 would be pretty adequate control, especially given the fact that we're going to now enable the meta character controls. So we'll go ahead and do that. Now, to the word or phrase sense, more so phrase, space is very potential to be used, so we'll go ahead and allow that. Now, it's not a statement or a statement of excitement, so we'll go ahead and disallow the exclamation. Now, we did see the hash symbol, so we'll definitely go ahead and keep that. Now, these characters, definitely not appropriate. They're not used in this context. We'll go ahead and keep the dash just in case, but these other ones likely will never be used, and certainly not in this case. The question mark and the @ symbol, definitely not going to be used. And same thing with caret and the tilde. And we'll come down here and add the comma in, just, why not? And there we go. So we have our characters pretty well laid out. We'll come through here and do the disallow, tab D, get that rhythm flowing. All right. And as said before, we're not going to do attack signatures here. We'll take care of that at a later point in time. We're just proving a point. And I do believe we can say that this is adequately set up. Data type 16. So we'll go ahead and create our parameter here now. And there we go. And that effectively does protect both of the parameters that are involved here. Now, let's go ahead and take a look at SQL injection blind. And we'll go ahead and test that one. No limitation. So we'll do Jim Bob. Submit that. Come down here. We've got a method of get, just like the previous request under SQL injection, and actually 404. So not found. User ID missing from the database. All right, cool. Makes sense. That's actually a bad thing, because that does imply that the user ID does not exist. So you have the ability to run through a list of user IDs and figure out which ones do exist. But advanced topics, not today. So to the point of what we're going for, we already have the ID protected, and within the same context in which we wish to protect for the other site, the same context applies here as well. Same thing for submit. Singular form, no repetition, no multiple ID lookups, no multiple buttons. So we can go ahead and kind of roll with this, and because of the protection that we've already provided for the other page, we're pretty much done here. However, we'll go ahead and add in our URL just for the sake of our policy structure. Wildcard it, no staging, and then match there. Just for the sake of explanation, you may wonder why I have not deselected this, because when I do enable attack signatures, this will actually take effect. However, for the current moment in time, because the overall global setting is disabled, these actually do not apply. So can I go ahead and create the parameters for the rest of the show with that enabled? Yes, I can. But to emphasize the fact that the signatures are disabled, I will keep them disabled very specifically on the parameters for the rest of the presentation. All right, so come back over here, and now we have this created. Now, as discussed, both of these cover both the SQL injection and the blind URLs and the lessons within DVWA for the protection, and they provide pretty full-on protection. The key reason being the characters that we do not allow. So most script-based attacks, SQL injection, cross-site scripting, command injection, they all tend to require special characters such as, the percent, the ticks, quotes, and the most important ones, or the most common ones, and certainly the most dangerous ones, would be the greater than or less than symbols. And often I just refer to them as script tags. So very relevant to HTML, JavaScript, etc., cross-site scripting. So by taking these out, this mitigates most of all your attacks kind of automatically. And with the additional characters, perceivably, most of these SQL injection attacks really could never succeed because they do require the use of these additional characters. Now, dash, we did allow that. So some of those attacks obviously very well could succeed to some extent, but by negating all the other functions, that pretty much mitigates that possibility as well. Now, there's the story of stored procedures, but that's a little more deeper, and that's not something that you can directly protect within the WAF itself, because for the most part, a stored procedure would be something that already is defined and essentially is considered a legitimate request. It's not something that we're looking for in the WAF sense. But if we do know there is vulnerabilities around it through, say, your application vulnerability discovery team, then from the WAF perspective, we can certainly provide additional layers of protection around that, potentially. Not necessarily always, but there's always opportunity for creative solutions. Now, we'll also take note here that none of these are set to deny or to disallow. Part of that intent is to demonstrate we were doing really, really good. We had a good thing going there, and we got them all set up. We were explaining things. Oops, we actually totally missed something, and we would have actually allowed all these. So essentially, we would have not achieved our goal. So let's fix that. Get our flow going. Tab D. And one more. And we'll go ahead and update that. And that pretty much concludes what we're going to do for the SQL injection lessons within DVWA to provide that 0-day complete to close mitigation. And we'll go ahead and move on next to the XSS DOM. The key reason we're not going to jump into the actual attack right now is just because we're going to focus on the WAF configuration first. And then once I'm complete with building out everything within the WAF, then we'll actually move on to replaying the attacks and see how well we did. So moving on, we'll go ahead and get on to XSS DOM. Same thing, we'll go ahead and take the URL, come over to our WAF, and go down to allowed URLs, and add our URL. And create. So with this one, the attack is focused on, again, the parameter input. So we'll go ahead and select, and well, first we'll take note that this is a list of languages. So please choose a language. So this is where we make some assumptions again. So we can go ahead and kind of assume that based upon natural language, that the names of natural languages and spoken languages and written languages more particularly, that it's going to fall within the length of that, within those lengths. So we'll go ahead and do select, and we'll take note that we have a parameter call to default, and the value happens to be the language name explicitly here. We'll go ahead and run Spanish and German, and we'll go ahead and do French too. And each instance we see it has changed with these names. Now, we'll go ahead and take into consideration the longest name of written or spoken languages is 24 characters long. So, with our 23 characters actually for that matter, including spaces. So with that into consideration, we'll go ahead and cap this out to 24. But keep in mind, the parameter we'll be protecting is going to be default. So come on over to our fancy WAF here. And there's our other parameters. So we'll go ahead and do default. No staging. As we saw, there is no empty value. So we will not allow it. And because in this case, it was a singular lookup, and usually this is kind of a singular function, so we'll not allow repetition. Back to what we mentioned earlier, we'll go ahead and go 24. And for our meta characters, we'll go ahead and similar situation to submit. Now, because language names can contain spaces, we'll go ahead and allow that, but there's no excitement. So we'll go ahead and disallow that. Hash symbol, because what we saw with submit, we'll go ahead and make the assumption there is the potential that this could be present. Actually, even though, as we see here, it's not. But back to some of the concepts, this is kind of how you take approach on some of your WAF policy design. So we could be super stringent and remove the hash symbol, but in this case, we'll go ahead and keep it allowed. So moving on, we'll go ahead and disallow these. And just for the sake that it is possible, like en-us, en-es, it's fair to go ahead and just allow dash, again, assumptions. But if we want to be super stringent, we could change that. So caret, not a character, tilde, not a character, same thing, D for disallow, and tap through it. Get the rhythm flowing. And tax signatures, again, not enabled. So we will go ahead and create that. And next, well, I mean, ideally, this one will be protected. So we'll go ahead and move on down to XSS reflected. And in this case, what is your name? Bob Jones. And hello, Jim Bob Jones. We can see name up in the parameter. So the name Jim Bob Jones up in the parameter, also appended by the hash symbol. And back again to the point of making the assumption hash is probably something we should just kind of allow by default. That's coming into a little more clarity in the situation, I would say. So this one, we'll go ahead and essentially do the same thing. We'll go over here and protect the name parameter. And back to the email aspect, this one's a little arbitrary just because you could kind of type in whatever you want, but we'll treat it the same as a user ID for the heck of it for the length, but we won't treat it for a user ID in the sense of characters. So we'll give it to 128, and we'll go ahead and disable these. It does need to be populated. Well, not necessarily, because we probably could click submit without it, maybe. Yes. Now, granted, it does have the hash symbol, but we'll go ahead and assume, like the others, it could possibly not be present, future application development intentions. So we'll actually allow the ability this time. Repetition, in this case, singular function, so we will not. Moving on to the meta characters, we'll go ahead and obviously allowing space, could be first name, last name thing, arbitrary, very vague on what is expected here. Oops. We won't move that over here so we don't screw up. And for the sense that you can kind of type in whatever you want. So maybe we want to have it show up with, what is your name? Jimba Jones. Nah. How far are you going to get with an exclamation character in an actual attack? Probably not very far. So for fun, for fairness, and looseness, we'll go ahead and allow that one to happen. Hash symbol allowed. Somebody wants to type in their name, like, you know, that'd be a funny one. Jones. Okay, that's fair. So we'll actually allow this. Asterisk, back to the other example with the ID, we'll allow it because it's not super dangerous in this case. Dashes, certainly allowed. It's common in names. So slash, we'll go ahead and allow that too. Colon, not so much. We'll go ahead and disallow that. These characters, certainly not allowed in the case of what we're going for here. So we'll go and disallow that. Carrots are not part of a name, nor is tilde. So we'll go and disallow these. Now, to the other characters we had shown before, because space can be converted to a plus depending on the browser and depending on the client and just a variety of cases. So we'll just go ahead and allow space by default, which is kind of why it's allowed by normal. Comma, not so worried. Period. Same thing with the exclamation. We'll just go ahead and allow it. So we'll just disallow these ones because the question already is there. What is your name? So you don't respond to a question with another question. So it's kind of how we're taking the thought process behind this. But again, can we go ahead and allow a question mark at a future point in time? Certainly. But we're building policies. We're building a framework that maybe we have to tune later. So we'll go ahead and create that parameter. And now XSS reflected here is actually protected. Before we proceed on to XSS stored, we'll go ahead and add our URL again. And make that a wildcard. And uncheck those. And create. And now we'll go ahead and proceed to XSS stored. So in this case, we have a guest book. Pretty straightforward, very common form input. The key thing is the ability to type a message. So this gets a little more tricky in what we get to do, but not necessarily. We'll kind of go ahead and start here. Jim Bob Jones is back again. And ooh, I can't type any more characters. So in this case, this web app actually has a fixed limit. Just for visual representation, it's 10 characters. So, okay, the web app actually has an enforcement to the length. This is kind of cool. This means that despite the fact that the web app has the ability to mitigate this on its own, it's still sensible for us to enforce it further on the WAF in itself. So we'll do that. Now, name, we'll go ahead and stick with Jim Bob Jones, but I can't do S anyways, whatever. Now the message, howdy. And there we are. We have an actual limitation. So I'm not totally sure what that is. We could certainly look in the web app in itself, but we'll use this to our advantage. And we'll do a count. So count characters, 50. So we know that the form has a fixed limitation of 50 characters. We'll go ahead and enforce that too. Because keep in mind, this is a limitation designed within the web app in itself. But if I were to use a proxy application such as Burp Suite or et cetera, I don't have those limitations because this is the form input limitation. It's not the actual limitation of what can be sent potentially. Even though the web app in itself may also cut it off, still it doesn't change. We don't know that necessarily for fact without testing it in ourselves. So we'll just go ahead and cut that out as a potential, and we'll mitigate it with the WAF as said. So for the moment, we'll go ahead and sign the guest book, and we'll take a look at our request. So coming through here, see a pretty typical request. We got our headers, got our cookies, and user agent. So nothing too special there. Coming over here, we see we have the form input for text name, which is Jim Bob Jones, as we saw. And then we have the message. And then finally, we have the button sign of sign guest book. Now, take note, this one actually did this as a form. So, hence why we have the request payload. And hence why the method is a post. We actually have a post body. Now, we'll go ahead and take a look at the actual raw payload. And we can see it's a very standard post body, where it is, for that matter, encoded. Despite what we saw here, it is decoded. But looking through, we have essentially the whole payload. So nothing special to really explain there, except for the fact that this is what's submitted and certainly what can be altered. Now, moving on, we'll go ahead and take a look at our cookies very directly. Nothing super exciting here. Now, we'll go ahead and because we have the ability to also clear the guest book, this means that this is going to cause some sort of interaction. So we may have to protect this parameter too, which we will. Just the question is, what is the parameter? Let's find out. And stuff, clear guest book. Would we like to clear? Yes, we would. Now, the reason why we submitted information is because we don't know necessarily or not if our request would include that information or if it simply would clear. So for the validation, get the full picture, we went ahead and submitted our information. Taking a look over here, oh wow, actually it is. So it justifies the fact that we'll have to protect it from the context of the clear button as well. But because the parameter names, text name, and MTX message remain the same, the protections it will provide in either sign or clear will essentially be one and the same. But keep in mind, here we have the button clear parameter name and very similar value what we saw earlier, where it was sign guest book, I believe. So we'll go ahead and work on protecting those now. And we'll come over here to our WAF. And before we really proceed, we'll make sure that we have our URL defined. Create. And again, wildcard. And create. All right, so now that the URL is created, we'll come over here to parameter list and we'll go ahead and create our parameter for this one. Or parameters. So text name, and we will not do staging because it's a singular value. And because it's a singular value, we will not do the repeating. But for empty, we didn't necessarily check if you can submit it without it, but we'll go and assume there's a possibility that you can. So we'll go ahead and allow the empty value. So moving on down, we know that we had a fixed limit of 10. So we'll actually go ahead and enforce that because the web app in itself does not allow you to type more than 10. So if somehow magically there's an extra character in there, that means that somehow you're doing something not within the web app form. So justifies our reasoning to go ahead and lock that down to 10. Now back to naming characters. We'll go ahead and allow space as we saw. You know, kind of like the earlier example, exclamation mark. It's not really going to hurt us. So we'll go ahead and allow it. And same thing with the hash because we saw it's pre-populated in some instances. So we'll go ahead and allow that as well. The name could put their brackets in, who knows, asterisk, etc. Not too worried about that. Colon, we'll go ahead and disallow that. Kind of not normal. Question mark, doesn't make sense to allow that. And caret, and same thing with tilde. So rinse and repeat. And there we go. We got our parameter created. Tax signatures not enabled. And we'll go ahead and create it. And take note, text name, lowercase the name. Same thing with submit as we created earlier. Now, as we saw for the message, that was MTX message for the parameter name. Come back over here and see that, MTX message. So go ahead and create that one as well. And because we saw we had a character limitation of 50, we'll go ahead and enforce that as well. And singular message, no repetition. Potential, it could be empty. Sure, why not? Wouldn't be the first time someone signed a guest book registry without a message. So we'll allow that. Staging, we know what we're doing, hopefully. And for the message, well, I mean, ideally, it's kind of anything that you can type on a keyboard. It's a message. So we should allow that, but it is fair for us to enforce certain aspects because, well, we're just going to be security hardened. So we'll go ahead and allow quotes. Makes sense to allow this one. $sign, you know, hey, you're making us a lot of money. Okay, we want to allow you to let us know that. Percent, oh, you just made us a massive percentage of income. Okay. Websites are a cash register to some extent. So money kind of speaks a lot in terms here, especially in the sense of comments. And symbol or ampersand. So of course, ticks, absolutely. We want to allow contractions. So semicolon doesn't hurt to allow this. Now, here's what we're not going to allow. We will not allow the script tags, which is essentially what these equate to. So this allows a lot of mitigation. This is why our ability to protect this from most any attack without without the use of the tax signatures actually will apply and well, do a pretty good job. But can we do better with signatures? Absolutely. And we will, but for the moment in demonstration aspect, no, we will not. We're just going to rely on this. These characters just don't make sense to allow, but because it is fair to allow the ability for the separation of a word, and or maybe they type it backwards, we'll go ahead and allow that. Carets doesn't make sense, but it's kind of there by default, and maybe someone makes a typo. Tilde, kind of not necessarily a conversational piece in words, but who knows? Could possibly happen, and it's not a very dangerous character, unlike the greater than, less than symbol or script tags. So we'll go ahead and keep that allowed. Now, as said, these are now allowed by default because they were previously disallowed. So we're not actually going to set disallow in this case. And tag signatures, again, disabled, so kind of good to go. We'll go ahead and create that parameter. And that pretty much takes care of our store page. Oh, wait, no, sorry. We forgot our button clear and we forgot our assign guest book. So we'll go ahead and create our button clear, and we see clear guest book. So that characters is, since we have it handy, clear guest book. 15 characters. So we'll take that into consideration as we create our parameter here. And just to reiterate, button clear, BTN clear. Helps if I type it correctly. And that'll bite you someday too, making a little typo like that. Like, why isn't it working? No, typos. All right, so empty value by design, this is a function, so it does require something to be there by, as we see within the application. So we'll actually require it in this case. So we'll go ahead and not allow. Repetition, it's a singular function, don't allow. Now to the value aspect, as we saw here, 15. So we'll go ahead and lock that down to, we'll say 24. Just to, maybe they want to create a few new functions, and it's not going to hurt us to go ahead and extend it a little bit further. Ideally, probably 16 is a little more appropriate, but we'll just kind of roll a 24 to give it a limitation of something, but still be flexible. So we'll roll with that. Now this one, kind of like when we saw submit earlier, we'll go ahead and lock this one down a little bit further. So these characters should not be allowed in the context of what we've seen so far. So no commas. And we'll actually allow a period, who knows, maybe they have a separation here. So disallow. And you may take note, some of these habits may change as you kind of go through it. Like maybe I feel a little bit more relaxed, maybe I feel a little more stringent. Just kind of depends on how you want to take the approach. What really does help though is consistency. So try to keep that in mind. But can you possibly forget as you move along, because these things do get pretty complex? Yes. Just make sure you make the appropriate choice, hopefully correctly to begin with. Otherwise, well, I guess you're going to find out the hard way and you got some tuning in your future. So there's our next parameter created. And then now we have the guestbook submit button that we missed a little bit ago. So Jim, Bob, Joan, something, get our guestbook parameter name, and we have button sign. Same context, sign plus guestbook. So we'll go ahead and rinse and repeat what we did for the clear button. And again, BTN sign. Doesn't hurt to double check. And we're gonna require a value, but not allow. And we'll set the same 24. And there we go. Now let's go and set them all disallow. And no signatures. Create. And effectively, we have just protected this web app as well, or at least this form. Next, we can go ahead and move on to open HTTP redirect. So with the open HTTP redirect, this one is not as obvious. So we'll go ahead and click here, quote, go back, quote to, good movies, by the way. But the vulnerability essentially is actually not visible per se, but we can see it down here at the bottom where it's showing us where the redirect or where the link would go. So for representation purposes, we'll go ahead and copy it and we'll open a new tab. And here we see the parameter that is essentially vulnerable, redirect. And it's going to an internal page, info.php. Now, in this case, because the web application is not sanitized to mitigate this, we can do something like this. And we go to a place that we didn't necessarily want to go. So with that, we can go ahead and protect that parameter, the redirect parameter, within the web application firewall. So first, we'll go ahead and create our URL like we've been doing. And we'll come over here and add it like we've been doing. Wildcard, enable, and go. Go to our parameter. And just to clarify again, our URL, or our parameter specifically for that matter, is going to be a redirect. So go ahead and create that. And same thing, no staging, because it could potentially be empty. I mean, in this case, no, it's not, but forward thinking, we'll go ahead and allow the potential for it to be empty because, well, I mean, if it's empty, who cares? In this case, if you're an authentication page, then you kind of want some parameters or things to be populated, like a session cookie. Not necessarily this is a parameter versus a cookie, but point in case could be relevant. So repeated occurrences, well, you can only be redirected once. So it's fair to say that that's impossible to have multiple here. So we'll go ahead and allow or not allow that. Make sure allow is set. Now for the length, this one gets a little tricky. Depends on the context. Like if you're just redirecting to a domain or a page, the length is going to be very short. But if you're going to redirect to a page with a domain and a URL, URI path essentially, then it certainly can get lengthier. If you also want to include a parameter, a query, such as like a Google click ID or a Facebook click ID parameter, then you need to make it longer. So 256 and 512 is a common one I tend to use. If I know parameters are going to be used, a lengthy one, particularly like a click ID, 512 tends to be a little more appropriate, and I've had to go even up to like 1024 and significantly further. But just to start out with, we'll go ahead and go with 256. Now I could do 128, and again, I'd like to just roll with bit values because bit values have reference to database storage limitations. They tend to be very limited around those kind of figures. So this is where the concept that I get, where I come from, in the sense of defining, 8, 16, 32, 64, 128, because back to the password example earlier with the fixed 32 character length, that actually is a database limitation of 32 characters in many, many, many situations. Again, not as common these days, SSL, SSO, etc. We won't go there another day. But for the moment, we'll just roll 256 because the length isn't so much the damage, it's the destination. So moving on. The characters, we'll go ahead and put controls here. For our typical URL, we don't have spaces, but we do have %20s. So this actually justifies allowing space regardless because it could potentially happen. Exclamation marks? No. Hash symbols? Yes, because of page kind of topic reference IDs. So parentheses and the rest of these, not really. Slash, well, it's kind of a URL, so we need to allow that. Dashes, absolutely. Question mark, certainly for the parameter. At symbols, this one's iffy. Usually you would not allow this, but in certain frameworks, it tends to be a common thing. So it's either it's there or it's not. So we'll go ahead and assume it's not going to be there. And in time, if we discover it is because framework changes or whatever, then we'll allow it. Same thing with these, not very common for web URLs, but are they allowable? Can they be seen? Yes, absolutely. But does it happen often? Not usually. So we'll go and assume no. And then plus, spaces get converted to plus in certain instances, especially when you do encoding changes. So we'll go and allow that, naturally allowed by default. And then period, well, it's kind of necessary for domain names. And we'll go ahead and set these all to disallow now. And overall, looking pretty good. Now, in reality, this is going to gain a lot of protection functionality from attack signatures as well, but there's some additional functionality that is really going to take care of this one, and we'll cover that here in a second. So first, we'll go and create this. And now we'll look at how this is actually protected. So we'll come down here to headers and redirection protection. And this is where we define the domain names that are allowable for a redirect to occur. And a redirect does require a 302 or 300, 301 response, essentially 300 of some sort, but a redirect nonetheless. So as long as a redirect occurs, then this gets invoked, this validation check. So it's validating to make sure that this is going to come from one of my domains, because evil.com is the example that we demonstrated earlier. Because that is not part of my domain list, this will automatically get flagged as essentially bad and be blocked if I so set the option to do so. Take note, I do have the ability to include subdomains if I so choose, so I only have to enter the key domain, and then all the child subdomains will automatically get included for simplicity purposes, but not always a good idea because it is potential that your DNS could have been compromised and someone could set up, myevildomain.waflogic.com. And they could have it redirected somewhere else because they compromised my DNS, and so they could send it off to a bad place. So this depends on how you want to take your approach. But in my case, because I manage all my DNS and we have it pretty well locked down, so we can make a fair assumption that we can roll with the ability to allow subdomains, but hopefully it doesn't bite me one day and I don't eat my words. Knock on wood. All right, moving on. So because evildomain.com is not here, again, it will be blocked. And we'll demonstrate all these examples and how the protection actually applies later on. We're just rolling with the WAF configuration. So by doing this, that effectively controls and takes care of all our needs for open HTTP redirect. Now, moving on to our next one, we'll go ahead and go with command injection. All right, so now on to command injection. Here, we're going to ping a device. So enter an IP address. That sounds kind of cool. Sounds like it could be potentially pretty dangerous because that likely implies that we're talking OS level commands. So let's just go ahead and see what happens. Submit. And it's clearly doing something. All right. Those are real ping stats. So that definitely tells us that we have a real live application here and we're interacting with the operating system level commands. Or at least very likely. I mean, doesn't necessarily mean unquestionably, but well, I mean, given what we see here, there's pretty good assumptions you can make that this just came directly from the command line. So we can likely execute any commands. Now, certainly that is actually the vulnerability that this web app does suffer from. So we'll go ahead and mitigate this with our WAF. Because again, the application remains unprotected, but we can patch it. And sometimes, more often than not, certainly historically, we can patch it faster than app dev. So with that in mind, there's our submit button, which was previously created. And there we go, submit. And we recall the context, so we won't revisit that. But we'll come down here and we'll take note that the parameter name is IP. Now, because of the context of what we're doing here, this is an IP address. So an IP address has a very specific format. In this case, this is the highest IP value that you can select, ideally more like a subnet mask broadcast range kind of thing. But point in case, this comes into your relation in the sense of character length. So we've got 4 characters, 3 digits in a period, repeated 3 times. And then we have 3 more without the period. So that gives us 15. Now, can we get a little more creative than just lock it down by 15 characters? Yes, we can. So let's go ahead and do that. Go ahead and type in IP, not ID. And no staging, empty value, potentially possible. Don't want to hurt block a person just because they clicked submit and it didn't populate an IP address. You know, no harm, no foul. And then repeating, well, we're only looking up one IP. The form only allows one. So yeah, we definitely want to lock this down just because potentially, who knows, maybe repetition, you can only block, maybe it will kind of look over one, but it'll actually take interaction with the last one. So the one initially looks good, but then with a repeat HTTP response splitting, in case there is the ability to potentially create multiple requests under one guise and be able to bypass it. So this is going to further lock this down. So we'll go ahead and maximum length, 15 characters as discussed. And here we get to use regular expression. And this is kind of cool. So we'll go ahead and drop that in. And yes, keep in mind, we'll add in our URL here in a minute. There's our regular expression. So back to the example earlier, we'll just type it here. That's our regular expression to go ahead and match an IP address of any length or value, and specifically only that. So we'll go ahead and roll with that. Go to our meta characters. So we could go ahead and lock this down out of the alphanumeric sense, but because the regular expression, and basically lock it down from alphanumeric to only numeric, but with the regular expression aspect, that pretty much enforces this automatically. But we'll at least go ahead and take out some of these characters, these special characters, just in case somebody needs to disable the regular expression. We'll at least have a baseline of some controls for the IP address. So we'll go ahead and move this. And we'll allow we'll go ahead and keep space out of this one just because an IP address does not allow space. We'll go ahead and kind of go down here and select, none of these are allowed, and none of those are allowed. Now, with colon, we do have the ability to do an IPv6. So colon could be potentially possible, but we're going to pretend in the sense that this is an IPv4 app only. So we're not going to focus on IPv6 just for the sake of simplicity. Good old IPv6. All right, so getting rid of the rest of the characters here. Plus symbols, nope, not in this case. Commas, nope. And we'll go with this. So disallow. And make sure we're looking good, nothing special. Okay. And create. Oops, we forgot something. Just goes to show, occasionally you can miss some things because these do get pretty complex, and there's just a whole myriad of potential possibilities in how you can protect something given within the context of what should be present. So we'll go ahead and update that and fix that one. And let's not forget our URL. Go ahead and go over here and take our URL. Now, take note that we do have this as the actual URL after the response. So we do need to actually create this one. And technically, because of this, we need to create two. So we will come over here and oops. So we'll create the first one. Now, we're going to wildcard this for that one. Now, you'd think potentially we could do something like this to go ahead and take care of the one without, but unfortunately that is not true. So because it does, this does imply that the character has to be present. So this will take care of the hash one if we wanted to, but in our case, we're going to be specific despite, the root potentially changing. So uncheck our boxes, go ahead and create, and yep. And then we'll go ahead and create the root or the base URL, or URI technically. And same thing. All right. So coming back over here, by doing this, what we've done with the WAF, we've effectively mitigated any potential command injection attacks upon this one. And because it is an IP address, it actually gives a unique advantage just because of how repetitious and expected the value is. And it's only digits and some periods. So that gives us a lot of control about what can be done on this one. So we're taken care of on that one as well. So another one knocked out. Now let's go ahead and move on to CSRF, cross-site request forgery. So with cross-site request forgery, CSRF, this one is a little more difficult to protect with the WAF. Just because ultimately what you're attempting to achieve is to take over an existing session or basically manipulate something in the middle, but ideally it should be a 100% considered a legitimate request. And the WAF by nature is designed to look for illegitimate requests in a textual nature, not necessarily a session-based nature. Now, some WAFs, including the F5, do offer a session-based tracking solution, but we're not going to talk about that today. Again, more advanced topics. And yeah, we're just talking basics. So here we've got the ability to change your password, yeah, we'll kind of go with that because we're already logged in. So new password, most secure one ever. All right, so we'll go and change that. Please don't save that. And here we can see that, essentially it was a GET request, and our URL contains the parameters. Horrible, horrible practice. Please don't ever do this. And if you ever catch it, yell at your developers. But nonetheless, we're proof of concept moving through this. So we have a password new and password confirm, and then our change function, which relates to the change button. And of course, we have our hash symbol again. So we'll take that into consideration. Now we also have this form here, test credentials. So developer tools, and let's get Jim Bob back in here. Now, just for fun, this one doesn't appear to have limitations on characters. So we'll take that into consideration. And then our password, let's type something. Gotta love those home keys. And then we'll go ahead and log in. Now take note, this one actually does a post. So there we have a post. And we'll kind of expand this here. So we get the wrong password for Jim Bob Jones. Big shocker. It was just a guess anyways. But nonetheless, we'll go ahead and look down here in the actual request. And here we have the username and password parameters. So, and also the login function relative to the button for that matter. Take note, didn't post it in the URL because again, we got a post request this time. And we can go and look at it further raw just to make sure what kind of format this is because the URL did decode that for us. So in this case, we know it's a standard post body versus, say, a JSON request. So we can create some protections around username and password and login as well. Again, the protection here that we can provide with the WAF basic aspect is only going to be manipulation of the fields. So, command injection, SQL injection, things like that. What we cannot do is protect a valid versus invalid session within this context. Now, again, additional features, there are other abilities to take care of this, but for WAF basics, we're just going to focus on, well, the basics. And we'll cover the advanced stuff in a future video. So moving on with this, we'll go ahead and go back to our F5, our WAF, and we'll go ahead and create several parameters. And for the heck of it, we'll go ahead and create our URLs. So we got our first one here. And rinse and repeat. And then we can come over to here and we'll also do the test credentials again, just to make sure the URL is the same, or maybe it's not. Let's find out. And as we saw earlier, no, it's not the same. So we have two URLs to create today for this set. So we'll come back over here and we'll go create another URL. I know, so exciting. And we'll do a wildcard again. So now that is created, we'll go ahead and create our parameters. Now, we could create the list of password current, password new, password conf, and password. Or we could potentially create some wildcards. So let's actually create a wildcard. Unfortunately, we will have to create two, but it's 2 versus 4. So we'll do password current, and because each one is password current and then new, and then conf. So the consistent part that we can keep static is password underscore. Then we could do the wildcard as the conf or new or current. And make sure we select wildcard. Staging, don't worry about. Allow empty value. Well, kind of required, but for the sake of refreshing the page or something to that effect, we won't punish our users. So we'll allow that. Repeated, this should not occur. Some web apps are vulnerable to repetition, so they'll look at essentially the last repeated instance versus the first one. So that's where you can potentially get around things. So we'll just kind of enforce this aspect. And then back to the password typical length of 32. We'll go ahead and enforce that. Now, a password tends to allow any typable character on the keyboard. So we'll go ahead and essentially allow any typable keyboard, but things like line feed, tab, while they're typable on the keyboard, they're not typable within a single line user input field. Now tab is, but because tab is considered a white space, it's often not allowed as a password. Not to mention tab within a web form usually will take you to the next field. So like password, it would probably, if you hit tab there, probably take you to the login button or submit it or whatever it is. Essentially the next field though. And if you hit shift tab, you can go back to username just for, or maybe the radio button. One case, tab essentially is a non-typable character for the input aspect. So the ability for you to type tab within there is impossible. So therefore we can naturally disallow it. Versus say a comment field sometimes will allow you to enter a tab. So we would have to allow it potentially there. Obviously we didn't earlier, but wasn't important because usually not common to enter a tab anyways. So moving on, password will allow space because some password systems won't allow it, but some will. We don't really know, but we'll just go ahead and allow it. And allowed by default, so whatever. Now, select these ones. Now to our evil characters, the ones we hate the most, script tags. Unfortunately, we do have to allow this. Now, some password policies will actually not allow those characters, but we'll go ahead and assume that we want to allow the user to have a secure password, and we don't want to imply that, well, our security sucks, so we don't allow script tags just because we're not sure. Versus having a confident posture, we can actually allow these because we have other methods of detection and controls. So we can actually confidently allow these script tags. And once we add our ability with attack signatures, then we can mitigate those cross-site scripting and etc. types of attacks. So this will do for as good as we can get without signatures and still be fairly effective. But again, we can't enforce the session aspect of whether it's a successful or unsuccessful password. So moving on, disallow, or wait, no, I'm sorry. Almost did that. So we'll keep all these as allow versus disallow, which we almost did right there, because we're, well, allowing these. Don't screw that up. Now, take note, we now have name metacharacter control because we created the wildcard here. So this offers the ability for the attacker to potentially create their own parameter names and potentially roll with that. And this defines what characters would be allowed within the context. And you could actually say something to the effect of, if these characters are present in the parameter name, then do not allow it. And this also, which is actually done by default, for that matter, we can kind of cover that real quick. That's under character set parameter name. Not go ahead and pull that up here. And here you have your character set by default, whether it's allow or disallow. Same thing with the values. So there you go. Not going to really get in depth with that one. So we're going to come over here and we're going to define what needs to be allowed or not allowed. So these ones are allowed by default, but because what we're covering here for the parameter is very specifically after underscore, for that matter, new, current, and conf. In other words, confirmation short. So only words, alphanumeric. So we'll go ahead and allow the typical alphanumeric anyways, but we're going to actually deny these. We don't miss it. And there we go. Now take note, the name characters are a lot more locked down by default, but nonetheless, and just for a little stringency, go ahead and disallow those. And don't forget, let's see, empty. Yep, we already covered that. So cool. Now we can go ahead and create that. So that covers our 3 parameters. Now we have the password one because there is no underscore, and even if there was, still, if it was just underscore, because there is the asterisk, asterisk does require character. So we just need to create the password specifically. All right. Form staging. We'll repeat. Lock it down to 32 length. Check characters. And need to allow. And ta-da. All right. We'll create that one. Now the next one we need to create is going to be username. And we'll do the same 128 as we did earlier for the IDs. And certainly we could create a regular expression for like an email address or potentially a normal user ID, but it's not exactly necessary. This should be adequate enough, but if you really want to go that route, go for it. It's not necessarily a bad idea, but computational cost versus reward, especially given the context of the length and character limitation, might not be such a benefit given the complexity of creating that regular expression and having to know a lot of aspects of your login versus we can actually get away with a lot of assumptions here. The regular expression would require a lot more in the know, but would it hurt to reach out to your app dev? Probably not. But do they always know? Not necessarily. Another topic for another day. Moving on. So username, spaces normally aren't allowed. So we'll go and deny those. No exclamation marks, no hashes. And then these, not allowed. Dashes, certainly possible. And no questions. No carrots. Could be a joke about that one, but nope. And we'll come down and sure, we'll go ahead and take out the comma. And we'll leave the plus. Well, sometimes I've seen instances where a plus is actually valid, so we'll go ahead and leave that. The equal symbol, I've had complications with this with certain apps, so I just kind of let it be by default. But if we want to really lock it down, we can go ahead and take it out. But there's a lot of more to explain on that one than worth necessary for this video. So that's the reason why we've completely skipped over it the entire time. Just kind of FYI. So moving on to disabling. Get that flow going. And we are good to go. All right. So as far as it goes, that's as best we can do with the WAF in protecting this web app. So we can only really prevent tampering and malicious activity. Again, we can't protect the session aspect directly with these features, but there are other features such as, like in our case, we have the session tracking. And then also we have bot protection and bot defense, actually, protection depending on the product. So some of those offer additional aspects, but again, advanced features that we will not cover in this case today. So that one's covered. Next, we're going to move on to weak session IDs. So similar to CSRF, we're not going to be able to do too much with the WAF here, but we can at least provide some basic enforcement and essentially some definition to the web application. So go ahead and generate our ID here, and go ahead and pull this, take note, post. So we have our response cookies, DVWA session 2, and just for the heck of it, the point behind this example within DVWA, we can see here, clicking it in multiple successions increases the session ID. Then we have the value, which is, a separate cookie. And then we can go ahead and take this one, but let me highlight correctly. And we'll throw it over here, do a character count, 202. As you saw, I already had one there, 202. So we'll go ahead and generate one more. And count that. And 202 again. So we can make some assumptions here that it will always be 202 characters long, and alphanumeric, and certainly DVWA, we see it incrementing by 1, so numeric value, but what limit does exist? Well, this we don't know. Is it probably more than 10? Probably. I mean, if you only allow 10 people to log into your site, then, totally cap it to 10. But if you have a multi-user site, more enterprise related, chances are you have several million user IDs, thousands to millions. Who knows, maybe even billions, but probably more like in between thousands to millions. Point in case, value here of a single digit probably wouldn't be a single digit in those cases. Hence why corporations usually use a much more unique strategy when setting a session ID. Nonetheless, what we can do here is just kind of define these cookies. And also we see here a request came with the PHP session ID. So we can certainly protect that and security, but how can we protect them? Well, we can come over here under the headers and cookies section, and we can go ahead and build out the cookies. Now, I'm not going to explain the difference between enforced versus allowed. Kind of a very, very F5 specific, but I prefer it allowed because I can control attack signatures and override them as need be. So we'll go here and we'll go ahead and create our cookies. So DVWA session, and it's an allowed. Form staging, no. Now we can insert the HTTP attribute, and we can also insert the same site and the secure attributes, but you have to keep in mind this is something that actually does manipulate traffic. So everything we've covered so far will allow or block the traffic, but it does not alter it. In this case, this actually does. So it may seem cool to go ahead and inject these attributes as you would like to ensure security, but could it break the web app? Very potentially. If they're not expecting it, if they're looking at the cookies in a different way, just a myriad of possibilities of reasons why this could really not work out in your favor. But doesn't change the fact that you do have the ability to insert them here, and it is a good idea. So this is something you have to be very careful on, but is it a good idea to ask your app dev teams if they'd like you to do this? Absolutely. So again, kind of a FI specific element here, but some other WAFs do offer this. Take note, we don't have character control or length control. So kind of some of those examples where I was talking about the length of the actual value, that sounded super cool, but we don't have those controls here. Why? I don't know. F5 just never developed them. Point in case, we can create some other methods to control this, such as custom signatures, I roles, custom roles for other WAFs. Just kind of depends, but in our case, very limited in what we can do, but we can at least, as you see, have all these signatures apply. Now, as we said earlier, we're not going to use attack signatures. This is essentially the only degree of control and protection that we can provide for the cookie in itself. And beyond, again, the session aspect, which again is more of an advanced feature, so not relative. So not too much we can do here, but at least a little bit to put something in there. And certainly to show you a few of the options available, just because, well, should I just skip this section? You would ask why. So I have to show you something. All right, let's go ahead and create the other ones. So PHP sesh ID. Now, one thing I also forgot to mention here, very important for the F5, this actually is case sensitive for cookies, regardless of the policy setup. So that can bite you. False expectations. Either way, we'll go and create this one. And as you see, it didn't lowercase it like the other one. So yes, it truly is case sensitive here. And for that matter, let's make sure I got the correct one because I just realized DVWA capital S. So close. But these are just important things to keep in mind as you go to build out these policies because so had I created that and had I ran with it without correcting it, then I would have had false expectations believing, oops, believing that the WAF would do something when in all reality it wouldn't match this. So had I created signature exclusions for this one, then it actually wouldn't apply because it's not the correct case. So the match didn't occur. So again, despite case insensitivity, sometimes even though the holistic policy is set to case insensitive, there are elements that could actually not necessarily be true for the case sensitivity aspect. And this is relative to some other WAFs. So it's not just an F5 kind of thing. So something to just keep in mind. Always be aware of what values, inputs, and how the controls for your WAF works. Every page could be kind of different because developers throughout the time usually developed these bolt-on components as the WAF matured and was created. So team one may not be there anymore, or may have worked on a separate team might have worked on a separate function, which is certainly likely as well. And so there's just usually different feels, sometimes for different functions. Very possible. So just things to keep in mind as you go through your WAF life. So that would be the two that we're going to protect there. And as said, that's pretty much the extent of what we can do here beyond some pretty more advanced controls that we could implement, but we're not covering that today. So our next is going to be file upload. And here we go. I'm not too worried about this because we'll still get the basic functionality of what we're going for. Oops. Thank you, demo gods. So with file uploads is kind of something that we can't do a lot about with WAF as well. This isn't tampering with a web application usually in the sense of what you need to protect with a file upload, but to the tampering aspect for a file upload, yes, the WAF can protect you from that. Just the contents of the file, not so much, but still to some extent, actually the WAF can protect you from some of the contents too. Just kind of depends on how the file transfer is done. And that's certainly per web app and how it's all built out. But in this case, it's more of a form base. So we'll go ahead and check this one out here. Create a URL. Look at that. We're building quite the policy structure now. And I screwed that. Here you are. And there you go. That's what happens when you make a typo. Could have not noticed that and ran with it. So try that again. Wildcard. Uncheck, uncheck, and create. Now, this is one reason why it is beneficial to create the URL structure, at least kind of to begin with in some cases, just to help you visually see how the site is built and how it all kind of works. So kind of like this, we can see vulnerabilities, everything really is under this path. So it is very potential that we could add a wildcard for vulnerabilities, or even remove the slash matching aspect where we could match multiple slashes with the wildcard and kind of cover this and shorten it. But this is something that we didn't necessarily know right off the cuff. As we develop our web app WAF policy, we've certainly become enlightened to this aspect. Now, the reason why this is a good point is because in the WAF space, we don't necessarily need any direct access or contact with app dev to manage a WAF and protect their web apps. So in this case, this is why we get away with a lot of assumptions based upon analytics and what we see over time, and we adjust as needed. Now, is there absolutely a need to have that communication? Yeah, of course. I mean, it really should be established. There should be some kind of back and forth, but for the most part, everybody should operate pretty independently, where WAF team essentially does their own thing and the app dev folks do their own thing, and we kind of figure each other out on our own because we're good at our jobs. And also we follow SDLC. So all these problems that could ever arise would be discovered in a lower environment versus production directly. So moving on back to the main points here, let's go ahead and see what we can protect. So we have our browse, and that's just going to pull up all your local file contents. And I have a PHP upload.php file. I wonder, can we upload this? Because take note, it says choose an image. And is it going to enforce it? Or is that just up to me to decide to pick and choose an image and not accidentally upload a virus? I don't know. Let's find out. Successful upload. Okay. Well, clearly it allows that. That dot dot slash is pretty terrifying. It's another conversation. But all right, so we come over here and we take a look at our request. Now we see the request payload, and for that note, post. And looking down here, and it's not kind of like the same form that we saw earlier, where it was parameter equals value, ampersand, parameter equals value, so forth and so on. Now, another special thing that we can see here that is very awesome, max file limit. So this web app actually does have a defined file size limit. What can we do with that? Enforce it. So we'll take that into consideration, 100,000. And then down here, this gets a little more complicated to kind of explain, but a couple of the parameters that this thing is going to see for the form data aspect is going to be name and file name. So we already covered name earlier, and by the way, there's our contents of the file, so you can actually see it pretty raw, and even calls out the content type in transit. That's not something we necessarily want to be uploading, but can we mitigate that with the WAF? To some extent, yes. We'll cover that here in a second, though. So for file name, we definitely want to put some controls around the file name, make it file name-esque. And then for the name, that implies the actual function of what's being done. In this case, it's actually referencing what the parameter is for the upload portion of this entire content for the form payload. So moving on, we've got a name and we've got the file name for the parameters that we need to protect. Come over here and we'll go down to our parameters. And for that record, we have name already. So we'll go ahead and do uploaded Keep in mind, we had a max file size of 100,000, and that directly equates to this one. So 1, 2, 3, and there we go. Now, empty value, if you just click the upload button without actually uploading a file, should invoke something on the page. So we'll go and allow the ability to have an empty value, but not in the sense of repeat occurrence, because this is a single file upload page, just like we explained earlier. So won't rinse and repeat that one. Value meta characters. This one gets sketchy. Just kind of depends on the type of file that you're uploading, and what you're going to allow. So sometimes you can allow this, sometimes you can't. Just kind of depends. In our case, we'll go and turn it on, and we'll run with defaults and essentially see what happens. So attack signatures, this is something that will definitely come into handy. So had we had attack signatures turned on for this case, that PHP info and system function calls, those actually will get flagged by the WAF. So that's one way the WAF would actually be able to protect you from certain kind of malicious file uploads in the sense of content. But the more encoded the file is, kind of like a PDF, zip file, etc., you can't inspect those with the WAF. Unless, of course, you have a virus service and totally separate advanced feature. So we're not covering that. Probably never will, because it's a WAF. You should ideally have some sort of antivirus and file scanning system in the back end handling all that for you as is. That's not the WAF's job to inspect that type of content at that depth. That's something that you can do kind of a little more efficient once a file is already transferred to begin with, given the fact we had it set within the limitation. So, we're not going to allow a 10 gig file upload in this case because the web app does not allow a 10 gig file. It only allows, 100,000 bytes. So nonetheless, that's the limit that we'll have. So we'll kind of carry on here. We'll go ahead and create this one. Now for the file name, 256 is kind of a normal file length limitation, but I've never really seen 256. And I've seen plenty of situations where 128 is kind of like a cap limit that's set. So we're just going to roll with that. And again, 256 is quite long. So we want some kind of limitation here. So we'll just roll with 128. And if we so discover that this doesn't work out in our favor, we could change it. Ideally, would I prefer more like 32 or 64? But I've had plenty of situations with federal document kind of cases where they tend to be a lot more longer file names, like dates, customer name, location, a whole bunch of detail all within the file name. So we'll kind of roll with 128 just to kind of set that middle line, a happy medium. For the character names, we can still force this one because file names do have certain limitations on what can be used. Now, different operating systems during different maturities, life cycles have changed what can and cannot work, but we'll kind of take a more basic approach. So we're not going to be as friendly as some file systems have become. Like your what copy of? No, that's a path. So we'll go ahead and allow that because it might be needed. And then these ones, no, no, and no. And just for the heck of it, we'll go ahead and pull over the comma. And we'll go ahead and set you to disallow. Now, we could allow the parentheses just because back to the copy of example or like new folder 1, new folder 2. But it's just like really poor file management that's being uploaded and usually implies just something stupid. I'm just going to call it what it is. So ideally, I don't like to allow that and call it out if it ever does come up. Potentially provide the argument of like, well, that's just kind of dumb, but it's not a hill you'd want to die on. So it's like, we shouldn't allow this, but if it comes up and like, hey, you block this, and I'm like, well, that was kind of dumb. I'm like, all right, well, it's kind of dumb that you're blocking it. All right, fine, I'll go ahead and allow it. So we'll start out this way, and this again is something you'd figure out through the SDLC lifecycle. So off the cuff, you can start out this way, lock it down pretty hard, and then you figure out what you need to allow. But then how much management overhead could you require down the road? You got to kind of pick and choose your battles. And I have pretty good ideas what I can get away with and what I can manage. So we'll roll with this. Now, staging, nope. Empty value, totally possible. And repeat occurrence, single file upload. So we're only going to allow one instance. And yeah, we'll go ahead and create that. And ultimately, that's about as good as it can get from the WAF perspective for the file upload controls. But at the very least, we can provide something to some degree. So if you're ever asked a question, is there something you can do? Like, well, not much. But at the very least, the answer is not no. It's like, well, sure, but not the greatest controls, but at least it's something. Do you have a good AV in the back end? All right. So moving on to the next one. With content security policy bypass, the goal here is to inject external links for this example here. So ideally what you're going for is something to this effect, evildomain.com, eviljs, and to include that. And there you go. There's your include, the request. And eventually it gets posted up in the body. You can look at the raw and find it in there. The key thing is we're going to protect this in the same manner that we did earlier with the redirect. So we'll go ahead and create the URL first. And same stuff. Wildcard, enable, and we're good. And as we saw again, the parameter include. So we'll go ahead and create that as our parameter. And include, no staging, potentially empty. Hopefully, yes, because we don't want to allow attacks. But ideally, the intent is to actually allow that. So in this case, because include actually can be done multiple times, granted by design of the form, it's pretty much one set kind of thing. But we'll go ahead and kind of go with the assumption that there could potentially be multiple ones on this. Even though we see one form input, but demonstration, we'll go ahead and lock it down to 256 characters, like we mentioned earlier with the redirect. And we'll come over here and we'll take out some special characters. And we'll take out our comma. All right. Get that flow going again. And no special characters we care about. So I'll disallow. And we will go ahead and create that one. And essentially, the CSP is taken care of because, as we mentioned earlier, we have our redirect protection, which is going to go ahead and ensure that only content from these domains will be allowed to be served or included in the context of what we're doing here. So by that effect, as long as the content comes from our company, then we should be safe. So again, not necessarily the ultimate protection, but it's something that we can do. And for that matter, in the cross-site scripting world, the CSP aspect, this actually does have a lot of weight in how it can protect you. So that pretty much covers that one. And now on to the final aspect that we're going to protect for DVWA and with our WAF. So we'll come over here to file inclusion. And with this one, you can see, we'll go ahead and copy the URL like we did before. What this DVWA is going for the lesson is to teach you about directory traversal. So within this context, reaching these files would be a direct call to, the file name. With directory traversal, you could do something to the effect of, //etc/password. So our goal is to enforce a little bit of control around the concept of what the page is going to be. So we know in this case, we can see that it's actually being sent to the same path as this page. And take note, we even have the parameter called page equals include PHP. So because this URL is consistently here, go ahead and create this one. And wildcard, create. All right, so back to where we're working with here, that was what? File1.php. So we'll go ahead and just capture that. Well, first, just for a little fun, show something here. Something broke. Bummer. Wonder if we can repeat that a few times. Oh, bummer. So, yeah, vulnerable. So our goal here is to go ahead and protect that. And as we saw, we had to get a little lengthy here. So we can use that to our advantage. So we'll go over here to our F5 and we'll go create a parameter. And we'll call it page, like it's supposed to be. No staging, allow empty, no repetition. So in our case, we know we're vulnerable to directory traversal, and we know that we cannot fix this web app because it was, built in summer 98 and cannot be updated because of reasons. So we'll go and do the best that we can do. So we see the file pages are file1, file2, file3, PHP. So we can kind of roll with that, and we'll roll with our typical computer byte length value. So we'll just pick 16 on this one. So double length of 8, even though I could totally protect that with 8 and it would be, valid. But we also have the file extension to consider. So we'll just roll with 16. And we'll go ahead and do some meta character control here. Now, because the file name shouldn't be including some of these characters, we'll go ahead and mitigate those. All right. Now, it is fair to say that many WAFs, including the F5 for that matter, do have a feature where directory traversal is kind of like just a default function. It's a global checkbox, which we'll check that out here in a minute. But what we just done here is effectively make sure that directory traversal still cannot succeed simply by the control of the slash, the whack, whatever you want to call it, and by setting it to disallow. So by doing this, you cannot traverse the directory at all, no matter what you try to do. Add some attack signatures, well, you get even further. But that simple global control that I was mentioning a minute ago, that's ultimately what's going to block this to begin with anyways. This is just another layer to say that we did, even more. And then back to the 16 length, because of what we saw, that 16 length, no matter what, they can't even attack it to begin with because it required more than 16 characters to get through. So we'll go ahead and create that. And then just to show you the control, it reloads. Directory traversal, which is, again, kind of the global control. And this actually takes encoding into consideration and some additional directory traversal methods available. So this is a much more inclusive, but why not? Like we said, we just took it out simply by doing the meta character control. So that pretty much includes what we can do here. Now, the one that we have not touched very specifically is the JavaScript. And this one is a little interesting just because with JavaScript, in this case, or the phrase that you're attempting to manipulate is something that is already defined. Now, we could put controls in here to limit what could be submitted. So as we see here, phrase, that's the parameter. We could actually lock it down to say, only change me is allowed. Ideally, submit the word success to win. Well, I mean, if that's the way to bypass it, then we would essentially want to disallow it. So what we can do is we're going to go ahead and do phrase. And we're going to just go with the idea that only change me is actually allowed. And if you submit success, you're actually doing something to bypass this. So again, phrase, just make sure. And then we'll go ahead and do the same thing we've done for quite a few others. We'll allow the empty, and then we won't allow the repeat. And sure, we'll go with 16. I'm just totally randomly guessing on that one. But really, we're going to go ahead and define a static list of things that can be submitted. So we'll go change me, denied, allowed. Oops. Nah, whatever, allowed didn't go in there. So we'll go ahead and go back in there and we'll make sure we put allowed in there. And take note, it did not lowercase these. So that definitely does imply that these will be case sensitive and they will not be case insensitive. So it actually does matter in this case as well, kind of like what was mentioned with cookies earlier. So just things to note. But there we go. We've got our allowed entries. And that's effectively what we can do in the sense of tampering here, because ideally it's going to be very specific on the web application. But if you do know what only is allowed for the JavaScript interaction, then you can actually define it. And like we just did there, and that'll give you that control. So if somebody deviates to the effect of, type success, then, well, it just won't succeed because it'll be blocked because, well, the WAF will take care of it. So that essentially concludes what we can do with the DVWA to protect it. Now, the next part we're going to go through is how good did we do? So I'll go ahead and replay some of the attacks and we'll kind of walk through this and, well, Let's see if we screwed up. All right, here we go. All right, so, well, now we're going to go ahead and launch the attacks again and see how well we did, like we said. So to do that, we first have to turn on blocking. So I'm going to do that real quick. And still apply the policy, but we'll do that kind of all one foul swoop here. So there we are, blocking, save, apply. And we're officially in blocking. Okay. So we'll come over here to our event logs. And stuff's going on. Go ahead and set this to a refresh. Every 30 seconds sounds great. And next, we'll go ahead and launch our attack here. Hmm. Oh, no, you're not getting very far, are you? And yes, it did identify that I am running an F5. You might have noticed at some points during some of our session here, we've had our cookie in our requests. Let's see if we can find you here. No, not in that one. There it is. So there's our TS cookie, and because it starts with TS, it's just kind of like an auto detect thing for systems like SQL map to go ahead and identify that, well, I was blocked and I see TS with this length of ID cookie. It's probably an F5 one. So that's how I was able to make that guess and an accurate assumption, or guess if you want to call it that. And well, we're kind of not getting very far in base comparison. So continue. We'll do no. And here we go. Do not appear to be injectable. Now, it is potential that we could go ahead and possibly increase this and maybe get something, but ideally not, given the fact of how much we've locked it down. Now, to kind of illustrate that, we'll go ahead and go through these. And for the matter, we'll go ahead and take out, we'll go after, good God, there's a lot of them. And so we can see, parameter, value, length, protocol compliance failures. That one's going to constantly pop up. And there we are. So under submit, it attempted to attack it, but because the expected value length is 16 and the set length we have it to control at is 16, and the actual value length ended up being 200. So it got blocked by simply that alone. Same thing with the meta characters. We can see that we captured by the parentheses and kind of go through here. We got 3 on this one. So we got parentheses and we got the pipe. So similar attacks. And take note, no attack signatures because we do have those disabled. And same thing, length 237 in this case. So taken out by that. Choose another random example. And take note, we also see no greens because I do log all events, whether it's successful or not. So anything that would have succeeded, I would have actually logged here too, and we'd see a green item, as we've seen in other scenarios. But in this case, no, it's picking up pretty much everything. So we got our tick, we've got our parentheses again, and it's kind of randomly clicking through here, everything is getting taken out like we'd hoped. We got 4 characters on this one. Parentheses. There's our colon. So you can see how effectively we've taken that out. Now, that was one of the SQL injection pages. So we'll go ahead and change up our thing here a little. And let's go ahead and confirm what the page is. Move back to SQL blind. And we'll change the URL in our request to this. Okay. And we'll go ahead and run that one too. Well, it's not doing so well. And no, don't want to reduce. Try as much as you can. And conclusion, all tested parameters do not appear to be injectable because it all failed. Because we are awesome. All right, so let's go ahead and take a look at those logs too. Just go ahead and refresh the page essentially. And we can see we're now on the blind page and nothing successful. Go ahead and go to the second page. See what we got there. All SQLi blind. And you can certainly see there's a lot of requests that are involved to make this all happen, or at least for the attempted to figure things out. But there's our separation point. And so here's the initial request that actually did succeed. As we said, green is 200, so meaning successful. You can see any of those anywhere else. So in other words, everything in between our test here and our test here did fail, minus this one. But let's go ahead and kind of take a look. There's not a single attack here. This is just the initial page request to make sure that the site is alive, likely. And then once it validates it's alive, then proceed. So in this case, what it did, and as said, it failed. So same thing that we saw in the previous situation. So we're not going to go through every one, but it's essentially trying the same exact attacks that it did in the other URL because the vulnerability remains the same. Just in the sense for the DVWA, they separated the two modules just for the sense of practicality because there are 2 different kind of contexts in how you could attack this one. So it's fair for them to create 2 different ones because, well, SQL injection is by far the most dangerous and the most advanced capabilities in which you can do when it comes to web attacks. So that pretty much proves that everything that we did is effectively mitigated, and again, with no attack signatures. So add those in, and we get even extra sauce on top of all that. But nonetheless, just this alone is good enough. So we've mitigated every potential 0-day for this parameter for the ID and the submit parameters by doing what we've done. So pretty cool stuff right there. Now, let's go ahead and see what we could figure out with our cross-site scripting. So, on to XSS. Go ahead and drop in. Can't do that right there directly, but we can do it here. So, Jimbob. And we'll go ahead and launch that one. We got blocked by our ASM, or Advanced WAF. And we can go, so clearly that one's taken care of. What's your name? Go ahead and do the same thing. And we get blocked there. And just for the heck of it, we'll go ahead and take a look at the F5 logs here. And meta character and value. And there's our script tags. Greater than, less than, inner quotes, semicolon, So we see one got allowed here. And cool, just the call to the page. Nothing actually bad there. Same thing with this one. Allowed. Nothing bad though. Here we go with the blocked event. We got two meta characters, so greater than, less than. And that has to do with a bit of the separation of, what we detected. Because again, we have this in the message field. So this is the one that we had more flexibility for the meta characters that we were blocking. In other words, more were allowed. But still, as said, because of those script tags, we went ahead and blocked this. So we still took care of the attack. And again, no attack signatures at all. So pretty cool. Go ahead and go back here. And for the DOM, we'll go ahead and do this. And essentially the intention here is to protect it from this as well. Boom. Just like the other one. So it's kind of like, even though it's three separate modules, the protection mitigation still essentially is very much the same. And there we go. We've taken out the cross-site scripting and the SQL injection ones. So we've confirmed that. Next, we can do the CSP bypass. And so we'll go ahead and put in HTTP right there. Include you. Well, that's really strange. I didn't get blocked. I wonder why. Because we have that redirect going on. But, oh wait, there's actually not a redirect that occurs here. So here's again, a great example on what you may expect to happen versus how the application actually behaves may not produce the same results of what you hope to have happen. So in this case, we can go right here and see our post, with the request include evildomain.com. I mean, the word evil by nature is, in the context of what the WAF sees, is not bad because it doesn't know how we perceive the definition of the word. It just looks bad to us. But for all intents and purposes, this actually is a valid request. Now, where attack signatures will actually come into play to mitigate this is because the HTTP part. So an attack signature will recognize HTTP in here and actually block based upon the fact that it's an HTTP external call. So you'd have to make an exclusion, but does the redirection protection apply that we had shown earlier? No, it does not, because none of these involve an actual redirect. You can see like 200, 200, 200. So there is no 302. And so unfortunately, because of that, that means the redirection protection doesn't actually work. And so, just presenting how to build a policy, but also some lesson learned as you get to go along and like, oh, well, I guess that didn't quite work out the way we were hoping it to. So yeah, it's definitely a good example to show you there. Now, next, we can go ahead and see what kind of controls for command injection. So let's go ahead and see how this worked out. So, we'll go with 4.2.2.2. That worked perfectly fine. And there we go, our results. So we can see that still works. Now let's do our cross-site scripting attempt, just because copy and paste buffer, why not? And blocked. We'll do bin / traceref. No, that didn't work. Let's see why. And here we can see we got violated on the length. So because we exceeded 15, and then we do not comply with the regular expression, automatic failure right there, and the biggest failure for that one. And then illegal meta character in the value, we have the WACs, so not allowed. No attack signatures yet again, and we still are successful in blocking this attack. So that concludes command injection. We've covered cross-site scripting, SQL injection. Then here we have CSRF. This one, again, there isn't a lot that we can do here, but at the very least, let's see if we can launch our cross-site scripting attack. So we'll come over here, refresh our WAF, and let's see what happened. There's our CSRF. And as we can see, password new, password confirmation. It did actually pick these up due to the actual length. So in this case, we have 46 characters beyond the 32. So you can kind of see that it's some of your attacks take up space quite quickly. So we'll kind of take a look at this one real quick here. And let's just do a single character. So you have to have something there, and otherwise the rest of this is required. 28. So you could still attack it within the context of a 32, so you still have to limit it down to less than 32. So it still can succeed, but most attacks kind of at least have that one, so it kind of gets you by. And then the more common one that you'll see is this. So that one is taken out. So to some extent, it is possible to get by this one. And just for demonstration purposes, we'll go ahead and do that. We'll just do the XSS here. And as you see, nothing actually was prevented. So this isn't necessarily for this specific scenario, not necessarily the 0-day to fix them all, but for the SQL injection and the cross-site scripting examples we did present, those actually can prevent very potentially, if not all, 0 days that could ever exist for this web app. File upload is next. Again, this doesn't matter. GD. So first, we'll go ahead and upload our PHP upload.php. Developer tools again. And go ahead and upload. And instantly rejected. So we'll come over here. And we'll take a look at why. And yes, I did pre-test this. So illegal meta character and value. Like mentioned before, in this case, a line feed. Now, that doesn't necessarily imply we can get away with this because ideally did block this, so good, but line feed totally could be bad. Nonetheless, we at least blocked it without signatures. So we'll come back over here and we'll go and test an image. And, oh, bummer, we did get blocked. So, known multi-part. This one I tend to find pretty useless because it doesn't really define where the problem is. Kind of like you can see here. There's no information over here to tune from, so it's either on or off. And clearly an image upload, we need the ability to upload the image. So ideally, we're going to have to turn this function off. No big deal. It's part of tuning. Request length. Now, keep in mind, earlier we saw we have 100,000, just like we see here. That's a max file size. So our file upload was 32,000 bytes. And we can come up here and we can check our request length. And we can see actually really in the end it's 33, but that's because of the additional headers and payload. So that's just counting the difference between the attachment size versus the actual payload. So that is a huge difference to consider because the F5 looks at it holistically versus just the payload individually. But within the parameter that we set earlier, that is where it does look at individually for the file size for 100K in that instance. So to set the limit for the actual request, which would be request length for no extension file type, and that essentially means a slash, like we see here, versus .php or PDF or HTML. And then we come over here and post data, and we see the 32,000 on this one. This is actually the data, not the headers, so hence the reason for the difference. So we'll go ahead and fix these two. And because of the concept that we have to consider beyond just the payload, the 100,000 bytes, so we'll go ahead and kind of take an easy number and we'll pick 3,500 for this one, just to, allow some sizable cookies and additional headers from, perhaps your CDN, and just to give it some buffer room, but still, as said many times before, we need to set some limitations no matter what, because who knows? The application could cause buffer overflow and DDoS us, depending on the context. Just, we need to set limitations. We're security, and we can do it, so why not? So first, we'll go ahead and fix this one. And that'll be okay. That's resolved. And we'll revisit, and we'll go ahead and fix again no extension under request length, and then we'll fix the post data length. F5 likes to move this one around. It's over here now for the moment. And we'll go ahead and take staging off. Request length. We'll do the 35, and we'll add a 0. So because there's the limitation for the file upload size of 100,000, I'm going to go ahead and go with 350,000. And the reason why is because we have to consider the headers and the cookies, and due to CDNs and third-party plugins, etc., I found pretty much if you add about 2,500, or essentially take what you need in this case and add 2,500 in addition, and that seems to catch a lot of it, but still you have some room to grow or reduce, but it's a reasonable baseline in between 25 and 3,500. So we'll go ahead and roll with that. And for the same thing as we saw earlier, we had the post data length that we're going to match to the request length. Now, granted, there's a difference because post data is the actual data in the payload versus the header size for request length. But as we saw, there's additional information, not just the payload of the file upload. So there's, the file name and the header and kind of the footer of the form data. So for simplicity, we'll go ahead and match request length to post data length. Now you can make them separate, and there are situations where it does make sense to do so, but it's a little easier kind of off the cuff to start out this way. And then when you get to your advanced tuning over time, this is where you can tune this down, but that gets a little more deeper involved. So to kind of start out and back to the simplicity of broad of what we're trying to teach in this scenario, we're going to go ahead and mirror these two. All right. And that effectively takes care of both of those two events. Technically all three, but we only needed to make changes in two areas. So we'll go ahead and retest that. Come back over and apply our policy. And it's applied. So we'll go and do the same image. And there we go. It uploaded. And now that we went ahead and uploaded the JPEG, we'll go ahead and upload the PNG and just see what happens here. Another image. Oh, bummer, we're blocked again. Let's go ahead and see why. And there we go. Post data length. And there we go. So, in our case, we're looking at the file size is a lot larger. So, because the actual web app does not accept more than 100,000 bytes, then in this case, we've exceeded that. So, despite the fact that this was blocked and was an image, might imply that we wanted actually to allow this, but because of the limitation of the file server in itself of 100,000 bytes, then this is actually fair for us to go ahead and still further enforce this and actually consider this successful in the sense of a size limitation. Now, for the ability to capture the PHP functions, we were able to capture that with the line feed, and as we see, we still have line feed intact, but line feed was able to block the PHP attacks for the functions simply because there were multiple lines in that case. And then for images, we can see that there is actually no line feeds for the image file in the actual upload. Otherwise, it would have blocked those. So that's one way you can leverage the meta characters to actually protect file uploads and still be able to upload files. It just depends on the type of file and the streaming method or file upload method, and deeper conversations for another day. Nonetheless, some basic little functionality. Now, once we do add the signature blocking back in play, those PHP functions for PHP info and system, those would be blocked by the signatures or rules for some other WAFs. Nonetheless, we've achieved some capability, and we've got some special kind of blocking without attack signatures. And so that concludes file upload. Next, we'll go ahead and do file inclusion. And on to the final bit of our show. We're going to file inclusion. So this is where we had the multiple files, and the key thing was we were able to do the directory traversal with the .whack, / and repetition several times, and then we were able to get the etc password in our earlier example. So we're going to go ahead and see if we fix that. So we'll go ahead and take this one. Let's go for this one. And we're blocked. See why. And parameter value length, 58 over the 16. As we said before, we set it to 16 for a common file name length or path. And got our illegal meta character, and there's the whack that we had talked about. So without signatures, yet again, we're able to mitigate this attack. So we effectively totally protected DVWA. One key point worth mentioning is we have brought up the word consistency a few times, and you'll notice that there were some inconsistent patterns in how we took some approaches, but the intent was to show you as you move along, you can change your behavior and how you want to approach things and do things a little bit differently based upon what you experience and what you discovered from initial policy design to throughout the maturity. At the end of the day, WAF policy tuning and WAF policy management will never stop until you actually unplug that web application from the internet. I mean, even after you stop developing on the web app itself, it's still very plausible to continue managing that web application policy over time just because there are new vulnerabilities that come out, and there's almost always room for opportunity for further tuning, as we saw to the depths of what we can do. Now, do we know for a fact through all the examples that we provided that absolutely this is 100% mitigated from a WAF perspective? No, certainly not. But to the depth and certainly to the time spent in the presentation, I would say we've done a pretty damn good job at making sure damn vulnerable web app is a lot less damn vulnerable. Sorry, but it felt appropriate. And yeah, this is to the effect of what you can do with the WAF if you have one of the most advanced WAFs in the world. Now, if you're playing with the most expensive Duplo blocks in the world, that would be AWS and Azure, then well, you might be able to achieve some of these results, but you are going to pay probably 10 times, if not more, the price of what you would pay with the F5, and certainly more an unpredictable price range per month versus actually paying a holistic contract per year. And same thing applies for quite a few of the other WAFs. Fastly, Akamai, they're an annual based contract and very predictable versus the AWS. And to some effect, some of these capabilities I've covered here are achievable with those. And you certainly would not pay extra to be able to provide these types of protections, very particularly for zero-day protection versus AWS and Azure. You absolutely will pay a hefty cost, especially the more that folks attempt to take advantage of that vulnerability and scan you for it, the more that you're going to pay. And the more complex that rule is, such as regular expression, the more you will pay until the vendor decides to come out of the rule. Again, AWS and Azure. So certainly the most expensive Duplo blocks in that sense. And again, to the comparison of $20 for municipal filtered water, that example still applies. So in conclusion, if you really want to do some amazing WAF work, then F5 ASM Advanced WAF is by far one of the best solutions you can pick, but there are alternatives that sit somewhere between that still provide an exceptional amount of protection with no special hidden costs. And cost is certainly an important factor because ideally cost should not be a consideration for your security engineering and how you want to design your protection for your company. That's something that's just an upfront cost for a product, like in most security product situations. I'm not sure why WAF is this uniquely commoditized thing now, but nonetheless, security is very important, so pick and choose your battles and pick and choose your poisons. And with that, we have quite the lengthy video that we produced for this one. But again, there was a lot involved, and we truly hope that you did learn something throughout this entire series. And we still plan to do some more videos, but for the moment, this at least concludes our DVWA. And we may pick up some more aspects of DVWA just for the sake of simplicity and consistency. It's easy for us to do demonstrations based upon this because it's an excellent utility to even do WAF evaluations, as we've discussed before. But nonetheless, we'll pick and choose our battles for our future videos as well. So stay safe, stay secure, and thanks for watching. Enjoy the holidays.